Hello students, look at your video, now back to mine, now back to yours. Sadly, your video isn't mine. Look at my hand. What is it? It's a periodic table of elements. Now look down, now back up. It's my cell phone. What is it made out of? It's made out of copper, lead, silver, and much, much more. I've burned half a calorie while speaking. Hi, I'm Alex Wu, and this is my chemistry presentation on topic number 15, the procedures used by nutritionists to find the amount of kilojoules stored in different food. So at the beginning of this project, I didn't really know what to talk about, so I decided to ask some of my classmates what they already knew about the subject so I could make an effective presentation. I asked a few of my classmates what they thought a calorie was, how they thought calories were measured, and what they thought thermochemistry was. And this is what I found. What do you think a calorie is?
Something in food that remains in your body that makes people fat.
Okay, wait, so servant, what do you think a calorie is?
Fat.
A calorie is a unit of, it's not a unit of energy, is it?
Yeah, it is.
Is it a unit?
It's a unit of energy.
What is thermochemistry?
Thermochemistry. It's hold on.
Actually, I know what it is. It's can you? Just delete it. I'm thinking.
The amount of energy you get from food, like obtained from food and absorbed in your body.
Okay.
Using the laws of thermodynamics to calculate.
How do you think calories are measured?
In joules.
No, but like how do you figure out how many calories are in food?
Why would I know all these stuff?
So I found that people had the general idea of what I was talking about, but to go over things, a calorie is a unit of energy and it's defined as the energy needed to raise the temperature of 1 gram of water to 1 degree Celsius. Some conversions we need to know are that 4.18 joules is equal to 1 calorie. On the other hand, 4.18 kilojoules is also equal to 1 calorie, except with the capital C. That's because a calorie, a capital C, is more commonly known as the kilocalorie or a food calorie, and it's equal to 1,000 small little calories. The system is actually quite confusing and it's quite old, so that's why nutritionists prefer to use kilojoules when they're describing food energy. Calorimetry is the science of measuring the heat of chemical reactions, and that's what I'm going to be talking about. But before we get into that, I thought it'd be good to explain thermochemistry, because it's the science behind it. And thermochemistry is the study of the energy and heat associated with chemical reactions. And we know that during chemical reactions, heat is either given off or absorbed. And of course, there's a law. Antoine Lavoisier and Pierre-Simon Laplace of France developed this law in 1780. This law states that the energy change accompanying any reaction is equal and opposite to the energy change of the reverse process. This actually helped to form the laws of thermodynamics. The Hess law, which is named after Germain Hess, states that the heat change in any particular reaction is the same whether it takes place in one step or several steps. So if you look at the diagram, delta H2 plus delta H3 is equal to delta H1. And we also need to know some terminology. Bond energy is a measure of bond strength in a chemical bond between molecules. Breaking these bonds requires energy, and it also releases energy as well. In 14.2 of a textbook, there's a table which lists out the bond energy of certain chemical bonds. We also need to know specific heat capacity, which is the amount of energy, measured in joules, needed to change 1 gram of specific substance by 1 degree Celsius. Enthalpy is a term to describe the amount of heat absorbed or given off in a chemical reaction. It's signaled by delta H. And if you read chapter 14 in the textbook, you'll learn about thermochemical equations. A thermochemical equation is basically a chemical equation written with energy included. And when we're talking about those reactions, we usually describe them as endothermic or exothermic. Endothermic meaning that the reaction has absorbed heat, and exothermic meaning that the reaction has given off heat. So if you remember, way back in chapter 4, we learned about double displacement, combustion, and Ward equations. And as I just explained, thermochemical equations include energy in the equation. So here we would have energy on the product side. So if we analyze this example equation, we find that this hydrocarbon burns completely because the only products are carbon dioxide and water. And we also know that this equation is exothermic because energy is written on the reactant side. If this equation was endothermic, energy would be written on the product side. Moving on, we also have to know this equation, Q equals mc delta T, which you may have learned in physics class. Q is the transfer of heat measured in joules, m is the mass measured in grams, C is the specific heat capacity, and delta T is the change in temperature. So here we have an example. Let's say I added 170 grams of Coke to water, and I burned that solution completely, and I found that the temperature increased by 40 degrees Celsius. That would give me a heat of 28,500 joules. To convert that to calories, I would find that I have 6.8 food calories. So that 170 gram sample contains 6.8 food calories. Now it may seem simple enough to do this when I have all the numbers and variables, but applying these principles, it's allowed people to develop calorimeters, which basically is technology that does this for you. And calorimeters are actually used in a variety of fields, and there's a whole bunch of uses, which I'll get into later. But nutritionists use a bomb calorimeter to measure the number of kilojoules stored in food. So what actually happens here is that this is an isolated system, which means that all the heat is kept inside as much as possible. Our food sample is analyzed by, it's placed into a container filled with oxygen and water. There's also ignition wires which help to send electric current to start the reaction. The material is oxidized completely, and this increases the temperature, and we can find the number of kilojoules stored. But actually there's a few downsides, because you can't imagine the food industry actually using bomb calorimeters for all of their food. This would produce a lot of carbon dioxide, which is bad for the environment. On the other hand, it also is a little inaccurate, because what happens with a bomb calorimeter, all the food is burned. And we know that when we eat food, not all of the energy is given to us because we can't digest some things like fiber. So we had to come up with another way to find calories. So what actually happens is the calories on the nutrition labels of food is actually calculated from all the individual ingredients. All those ingredients are broken down into nutrients like organic acids. And we have a list here of some of the common nutrients: proteins, carbohydrates, and fats. And it's known that 1 gram of protein contains 4 calories. 1 gram of carbohydrate contains 4 calories, and 1 gram of fat contains 9 calories. So what we can do actually is calculate the number of calories in food. And that goes on to our nutrition labels. So what now? Well, basically I tried to explain thermochemistry to you, which leads into calorimetry. But what is the point of all of this, as Chauvinast said before? Well, basically now I'm going to get into some of the industry applications and the benefits to society that this science has brought us. So some of you might be sitting there thinking, great, I know a little bit about thermochemistry, I understand how chemical reactions work in regards to heat, and I understand how nutritionists measure calories. But then you're thinking, what exactly is the point? How does this affect me on a day-to-day basis? Well, in a survey in 2004 by the Canadian government, it found that the average male, 14 to 18, consumed 2,894 calories per day. The average female, aged 14 to 18, consumed 2,047. So through the application of thermochemistry, which led to bomb calorimetry, which has led to other processes, we're able to have accurate nutrition labels on our products that we eat. Benefit of this is that we're able to make informed decisions about our diet. We're able to know what exactly we're eating, and we're not being misled. A Canadian initiative in this field actually happened recently in 2007. Policy was implemented in which all prepackaged food had to have nutrition labels. It had to list the amount of calories, fat, nutrients, a lot of stuff. In fact, we actually set the gold standard because we are the first country to include trans fat on our nutrition labels. Something to be proud about, I guess. So a benefit to society is that we have accurate labels, we know what we're consuming, and we can make informed decisions. Calorimetry is also used in the food industry to measure shelf life. So we know exactly when the food is going to expire. So that's another benefit. And as I said earlier, calorimetry has uses in other applications as well. It's used to test fossil fuels to determine the amount of possible kilojoules there. Hot and cold packs use this technology. Also, an important use is for safety. It's incredibly important to know when exactly how much heat you're releasing when you're dealing with rather large-scale chemical reactions. Ms. Botticelli would know this as well, because the pharmaceutical industry also uses calorimetry to determine the properties of certain drugs. So there's a lot of good benefits to society, but with anything, there's also risks as well. Especially when we're burning so many things. Obviously, carbon dioxide is produced, which is bad. There's also a risk with controlled exothermic reactions when you're doing large scale. Things could go wrong, and there could be more heat produced than removed, and this leads to a volatile increase in temperature, which can lead to fire, injury, death, a lot of bad things. Also, in the food industry, food additives and preservatives are also added through chemical reactions. And we don't always know exactly what additives are added, and this could cause underlying health risks. As I mentioned earlier, Canada is actually implementing the new food label system. The food industry has estimated that it was going to cost $260 to $400 million to implement the system. So that might cause an increase in food prices. On the other hand, Health Canada has projected that we're going to save $5 billion over the next 20 years because of dietary improvements that have been a product of better nutrition labels. And finally, on nutrition labels, while it's good, restaurants and other fast food places are still not required to list out all the calories, all the ingredients to their food, and neither is alcohol. So there is still that. So through my presentation, I hope you've come to understand the basics of thermochemistry, how it's applied, and how it relates to you on a day-to-day basis. Thank you for watching.